In this video, we're going to be looking at our cable system. So we have a question that looks like this, and they said, determine the forces acting in the cable, your AB, then and region CD by using the given figure as a free body diagram. Make a section between B and C and the appropriate sketch and the necessary calculations to find cable force T between BC and distance HC for region CD. So your HC would be this one. You see? So first thing that I like to do with this one is to write my components at my endpoints. Where are my endpoints? My endpoints at my A, I'm going to have what? I have my AX and I also have my AY. This side I have my DY and I also have my DX. So that would be the first step. Then the second step is to try and calculate this AY and DY. How can I do that? I can do those by using the formula for sum of the moment. In order to find my AY, I will take my moments around D, and in order to find my DY, I will take my moments around A. So let's start with that. First thing first, we're going to start by taking the sum of the moments around A. Even at D, it doesn't matter as long as you'll be able to get them. So you decide your choice of direction, that let your clockwise be positive. So whatever that is going to be moving in your clockwise direction, it's going to be positive. And always remember how a normal clock moves. It always moves in a clockwise direction. So we're going to say we have some of the moments around A. What do we have? We have this 1000 which is going in the clockwise. We'll say we have that 1000. We multiply by the distance between this force and our A, which is going to be 2. Then we have the 500. What is the distance between the 500 and this one? That's going to be multiplied by the 4, plus we have this dy. The dy is acting in a anti-clockwise direction, so we'll say we have minus dy by, what is the distance between dy and ay? We have 3 plus 2, it gives us 5, plus 2, it gives us 7. Then we'll say this, it's equals to 0. So we will have our 2000 plus, I think this one, yeah, still 2000 minus 7 dy, this is equals to 0. We have 4000 minus 7 dy, this is equals to 0. Then you take your 7 dy to the other side and divide, and you'll say your dy would be equals to what? It's going to give you your 571.43 Newton. That would be for your dy. You go and write it that, okay, for this one I'm getting my 571.43 Newton. So since we've got that one, we can just come and erase. So make sure that you are writing this as busy doing the calculations, so that you are able to follow up with the steps. So the second one, we're going to take some of the moments around D in order to find our AY. So you start again by choosing your choice of direction, that still I'm going to let my clockwise be positive. So we'll say some of the moment at D. What do we have? We have this one which is going in a clockwise direction. We will say AY multiplied by the distance in between. It's 247, plus then we have this 1000. This 1000 is going in anti-clockwise. What is the distance between B and D? That will be 2 and 3, and it's going to be 5. So we'll say it's a negative because it's in anti-clockwise, multiply by that 5. Then we have this 500, which is a negative because it's going in this direction, multiply by 3, and this is it's equals to 0. We have 7ay minus 1 minus 5,000 minus 1,500. This is equals to 0. Then we're going to have what? We're going to have 7ay minus 6,500. Then this would be equals to 0. Therefore, we can say our ay would be equals to what? We'll say our ay will be equals to our 928.57 Newton. So we found our ay as 928.57 Newton. So we found those ones. Then remember, I'll just have to erase this one because I do not have enough space. So you found your ay and your dy successful. One method that you can also use to verify that you've done these things correctly is that you will say you have some of the forces that are going up is equals to the sum of the forces that are going down. So the forces that are going up, you have 928.57 plus 571.43. These are the ones that are going up. The ones that are going down, it's your this and this. So this one and this one should give you 1,500 in order for these ones to be balanced. So another way that you would use is that you would take some of the moment around 1. It can either be A or B. Then you come back and use this formula without having to go that normal route of calculating some of the moment at 2 points. Then you will, if you use this one, you're trying to balance them out. But use this one if you are sure that you did the correct calculation with that 1 point where you were doing the calculations. So now comes another step that you have to do. With this step, you have to calculate your ax or your dx. So what I like to do is that I like to check a rectangle that has most information. If you can see, this one has most information because they've even given you this 1 meter this side and the 2 meter this side. So if I can be able to cut here, it means I'll be able to work out that ax. So okay, let me just do it for you so you see. I'm saying if I'm able to cut here, what am I going to be left with? You're going to be left with only this triangle to work with. Remember, you're having this, then this is where you're having that 1,000, then you're having your ax and your ay and your ax. You have your 2 meter, then this side you have that 1 meter. So now we're going to be taking some of our moment around B to find our ax, because remember this one is given, it's here. What are we going to say? We're going to say some of the moment, we'll still say let our clockwise be positive. So some of the moment at B, now we'll say we have what? We have this one which is in clockwise, it's our ay. It's what? It's 928.57 multiplied by 2 plus this one, it's in anti-clockwise, so it's going to be minus ax multiplied by 1. This is equals to 0. See, so this is the same as 1857.14. You have 1857.14 minus your ax is equals to 0. Therefore, you know your ax will be 1857.14 Newton. Then it means we can go and write it this side that we have our 1857.14 Newton. 14 Newton. So we found that one, and if we found that one, you do see that AX and DX are the only ones that are acting within the horizontal axis. So you can come this side and say, if you have some of your forces in your X direction, what are you going to have? You have your AX, which is going that side. You're going to have minus AX plus your DX, which is going to the right. You equate them into the, but we know our AX because we just calculated it. We have minus 1857.14 plus our dx. This will be equals to 0. Therefore, dx is also equals to 1857.14 Newton. Then we can come again this side and say we have our 1857.14 Newton. See? So okay, we're done with our AY and AX and DX and DY and DX. So what's next? So what's next for you is to look at your endpoints. You have your A and your B. So now we're going to look at what? We're going to look at these triangles that you're seeing at the end. Remember these lines, yeah, you have this one which looks like this. This side you have this one which looks like this. And one thing to notice again is that, okay, if I'm going to consider this shape, I have a shape that looks like this. Then I have this line which is my CD that's in the middle. So basically means this side, if I say it's dx, then this would be dx, this would be dy, this would be dy. So the same here, if I'm having my dy within this line, then I can say also this within this triangle that you're seeing. I can also say this here, or this side will be my dy, because this dy is also acting along here. So I can come and say, okay, here I have my 571.43. Then here on the horizontal axis, I can still input this one, which is my dx. Then right, I have my 857.14. Then this side, we're going to do the same interpretation. Within my ax, I have this value, which is my 1857.14. Then what's happening on my y-intercept? I do have this one. So same thing as this one. What do you have? You have this shape that looks like this. Then here you have your AY, and I said if this side is your AY, then it means even this one is your AY. You have this one that is in the middle, which is that AB. Then it means here it's where you're having your AX, and also here that's where you're having your AX. So now it means I can come and say I have my 928.57. Then remember, this is my AB. Then this side, I'm taking this one. Here I was taking this one, if you can notice. And here I was taking that one. So I will say I have my AB, here I have my CD. How do we find these ones? We find this by using Pythagoras theorem. You will say you have your AB is equals to your square root of 1857.14 all squared plus your 928.57 all squared. Then this side you will still say your CD equals to your square root of 1857.14 all squared plus your 571.43 all squared. And you have to find for each and every of those. Therefore, for your AB gives you your 2076.10 Newton. Then your CD gives you your 1943.9 Newton. And also one thing to note, I lost my Casio, so when I was calculating this, I was just doing them on phone. So you might get the rounding that's a little bit different. So take note of that one. So we're going to say we've calculated our AB. It's what? That's 2076.10 or whatever value that you're going to get on your side. Then this one we've calculated it as 1943.07 Newton. So now we were successfully able to determine the force in A, B, and C. So now we have to come back and do for the one that's in the middle, which is our BC. Then when we get to our BC, that's when now we actually do the actual method of section that they've told us to do. So they actually told us that we should be able to cut in between B and C for us to be able to find that force within that cable. So forget this first cut that I did here. Now we're going to do a cut that will look like this. Then what would a free body diagram of point C look like? So at point C, we're going to have this. We have a force that is going down, which is your 500. Then we also have this force here, which is going this side, which is your BC. Then we also have this force that is going that side, which is your CD. You see? So now we're actually supposed to find what? We're actually supposed to find our BC. But the problem, we don't have this angle. Let me just call it theta. If we don't have this angle, what can we do? We can actually try to work this out using our components. What do I mean by that? It means now we're going to be having something that looks like this. We still have that 500 here. Then here, our BC, we can say we will have what? We will have your BCX, and this side we're going to have your BCY. Then now when it comes to this CD, you see this CD, we were able to determine the value that it's 1943.07, but we don't have this angle. But what do we know? What do we know from the interpretation that I gave you? I said you can interpret this as being a full square. So it means this one going up, you can take it as your dy. So you can take this one as your dy, because even if you were to work this one with your component, you will still need to find the component that is going to go there, which is going to be your CDY. Then here you're going to be, no, CDX I meant to say. Then here you're going to find your CDY, but which is all what we already have. Our CDY is the same as this, not the CDY. Why am I doing the CDY? It's going to be your dx and also your dy. So it means we can just come and say we have that 571.43. Then this side we have that 1857.14. You see? So I just hope that explained the part nicely. So now we consider some of the forces in the x direction. That okay, we have this one. Remember, if you're looking at this it's more or less like going down, then the one that is there it's going up, then this one is going yeah, like that. So now we will say we have what? We have minus BCX plus this one that is going to the right. It's your 1857.14. This will be equals to 0. Therefore, if you solve this, you will get your BCX being equals to your 1857.14 Newton. Then now you do the same thing with some of the forces in your y direction. You will say some of your forces in your y direction. So some of the forces in your y direction, what do you have this one which is going in the positive direction. You will say 571.43 minus your 500 minus your BCY, then this will be equals to 0. This 571.43 minus 500, you get with 71.43 minus BCY, this will be equals to 0. Then you can conclude and say your BCY is equals to 71.43 Newton. So now if you were able to find the components for BC in terms of BC X and BCY, it means you can be able to use the Pythagoras theorem, because now what do you have? We have this triangle that you see here. It's looking like this. We said, what is our BX? Our BX, we found it was the 1857.14. then BCY this side is 7.43. then this is the actual BC they are looking for. So now we can say, what is the BC? We'll say BC is equals to the square root of what? The square root of 1857.14 all squared plus your 71.43 all squared. You see? So this, it's this one. Then what are we getting with that? We get 1858.51. You get your 1858.51. So for you, you're rounding off. It might be a bit different as I've explained. Then this is in Newton. So it means now we have to go and indicate here that, okay, for BC we got what? We got 1858.51 Newton. So now what's left? What's left is for you to determine this angle that you see here. How would you determine that angle? You can determine this angle actually by using this triangle that we've written here. So how would that look? So I'm just gonna try and erase this part here because we're done with that one. So apologies for that. So I'm just gonna, since you've already know this ones, then how would you find that small part? So we do have this, and we can just say this angle that you see here, it's beta. So if we want to calculate beta, we know this angle is opposite to this. So we can say we have tan of beta is equals to your opposite over adjacent. Then you're going to have what? You're going to have your 71.43 over your 1857.14. Then you know your beta is equals to your arctan of your 71.43 over 1857.14. Therefore your beta would be equals to how much? You have to find that one. Do I have it with me? Did I calculate this one? Okay, your beta is going to give you an angle of 2.20 degrees, and it actually makes sense because this looks small. Remember, this side it's 1 meter, and whatever that you're going to get from here to here being HC, it can't be more than 1 meter. It would mean you have done the incorrect calculation. So since we found this angle, how are we going to find this portion this side? So we can say we have what? We still have this triangle, which is this one. I'm gonna redraw it and say we have that 2.20 degrees. Then now you have to be able to see how we are playing with these shapes, we're going to take this 2 meter that you see outside, then we're going to put it here because it's given. Then now we're looking for the x that is unknown. So we have the x that is unknown here. Then how can we find the x? We know that we have this angle here, which is this one that is opposite to that one. We can still use tan, and we say we have tan of 2.20 degrees. It's equals to what? It's equals to your x over your 2 meter. Then your x would be equals to your 2 meter multiplied by your tan of 2.20 degrees. Then you get your value for your x. Then this would give you how much? It would give you your 0.0768 meter. And it actually makes sense because it's a smaller portion. So since you found your x, we also had to find out our HC. So how would you find your HC? You can then conclude that, okay, in order to find my HC, I will say I have my HB, which is my overall, minus the x that you have this side. So you can say your HC will be equals to your HB, which is 1, minus your 0.0768 meter. Then now you're going to get that final value for your HC. Then that's basically how you solve this type of questions. So if you found this video useful, please like and consider subscribing.